In the far reaches of our solar system lies a planet so distant, so cold, and so mysterious, it seems almost otherworldly. Neptune, the eighth and farthest planet from the Sun, orbits at a staggering distance of 4.5 billion kilometers. Yet, despite its remoteness, Neptune's beauty has captured the imagination of scientists and dreamers alike. The planet's striking blue hue stands out as a beacon of wonder in the vast, dark expanse of space. But what is it that gives Neptune this brilliant, almost surreal shade of blue? Is it simply the light of the sun reflecting off its icy surface? Or is there something much deeper at play? To uncover the mystery behind Neptune's stunning blue color, we need to venture far beyond our home planet. Beyond the familiar worlds of Earth, Mars, and Jupiter, there exists a hidden realm, a realm of icy giants where the dynamics of light and atmosphere create incredible phenomena. Here, on Neptune, the answer to its blue color lies not in one simple factor, but in a delicate dance between atmospheric composition, the interaction with sunlight, and the planet's own unique characteristics. Let's explore the science that brings this world to life. Neptune's atmosphere, like that of its neighbor Uranus, is primarily made up of hydrogen and helium, two of the most abundant elements in the universe. But what makes Neptune distinct is the higher concentration of methane in its atmosphere. While methane is also present in the atmospheres of other planets, its role on Neptune is especially important. Here, it holds the key to Neptune's vibrant blue. Methane, despite being colorless on Earth, behaves differently under the extreme conditions of Neptune's atmosphere. When sunlight reaches Neptune from the distant sun, it must first pass through the upper layers of the planet's thick atmosphere. And here, methane plays a critical role. As sunlight passes through the atmosphere, the methane molecules absorb light at the longer end of the spectrum, the red, orange, and infrared parts of the light. But the shorter, blue wavelengths of light are much less affected. Instead of being absorbed, they are scattered by the methane in the atmosphere, much like how the Earth's sky is blue due to similar scattering. However, this scattering process on Neptune is even more pronounced than on Earth because the methane in Neptune's atmosphere is both denser and more abundant. This causes the blue light to be reflected back into space, making Neptune's color seem almost electrifying. The result is a planet that radiates a brilliant blue shade, a color that has fascinated astronomers for centuries. Neptune's atmosphere is far from static. In fact, it's one of the most dynamic environments in the solar system. The winds on Neptune are among the fastest recorded in the solar system, reaching speeds of up to 2,100 kilometers per hour, faster than the speed of sound. These extreme winds stir up the planet's atmosphere, mixing gases and clouds in ways that we're only beginning to understand. The clouds on Neptune are composed primarily of ice, mainly methane ice, but also water and ammonia ice. These high-altitude clouds reflect and scatter light in ways that enhance the planet's overall blue appearance. When sunlight hits these icy clouds, they reflect the blue light, contributing to the overall color we see from space. While these clouds are important in reflecting and scattering light, they're not the only factor. Neptune's weather is highly volatile, and its atmosphere is constantly changing. The planet's strong winds and massive storms, such as the Great Dark Spot, a storm system the size of Earth, play a significant role in shaping its visual appearance. These storms can mix up the cloud layers, causing the atmosphere to become even more turbulent and altering how light interacts with the clouds. In fact, the shifting nature of Neptune's cloud systems may also contribute to variations in the blue color we see. Some regions of the planet appear a deeper, more saturated blue, while others are lighter or even streaked with white, depending on the movement and concentration of clouds and gases in the atmosphere. At the farthest reaches of the solar system, sunlight is faint and weak, taking over 4 hours to travel the 4.5 billion kilometers from the Sun to Neptune. This means that the energy Neptune receives is a fraction of what Earth experiences. Yet, despite this diminished sunlight, the interactions between the Sun's rays and Neptune's atmosphere are still powerful enough to produce the planet's blue color. Much like Earth's sky, Neptune's color is influenced by a phenomenon known as Rayleigh scattering. This occurs when sunlight interacts with the gases in the atmosphere. On Earth, Rayleigh scattering causes shorter wavelengths, like blue and violet light, to scatter more widely, making our sky appear blue. But on Neptune, the process is amplified due to the planet's methane-rich atmosphere, which is especially good at scattering these shorter wavelengths. The presence of methane in such high concentrations means that blue light is scattered in all directions, contributing to Neptune's vivid blue color. The result is a planet that reflects and radiates blue light far more strongly than any of the other planets in our solar system. While the sun's rays are weaker at this distance, their interaction with Neptune's atmosphere still manages to create a stunning visual effect. While both Neptune and Uranus share similar characteristics in terms of their gaseous composition, their blue hues are strikingly different. Neptune's color is far more intense. It's blue deeper and more saturated, while Uranus appears more of a pale turquoise. This discrepancy begs the question, why does Neptune appear so much bluer than its neighbor? The key difference lies in the amount of methane present in each planet's atmosphere. Uranus, with its thinner atmosphere and lower methane concentration, reflects less blue light. Neptune, on the other hand, has a denser atmosphere with more methane, which scatters blue light far more efficiently. This results in Neptune's richer, more vibrant blue color. Moreover, Neptune's storm systems may also play a role in accentuating its blue color. The turbulent nature of its weather, combined with high-altitude clouds and the distribution of methane, could be contributing factors that make Neptune appear bluer compared to Uranus. Despite the advancements in our understanding of Neptune's blue hue, much remains unknown about the finer details of the planet's atmosphere. As we continue to study the planet with new tools like the James Webb Space Telescope, scientists are uncovering new insights about Neptune's composition. For example, the exact nature of the clouds and gases that contribute to the scattering effect remains an ongoing mystery. Some scientists hypothesize that there may be other compounds present in Neptune's atmosphere, compounds such as acetylene or diacetylene, that could enhance its blue color. These molecules might be involved in complex chemical reactions that alter the scattering properties of the atmosphere, further influencing the planet's appearance. As new missions explore Neptune and other distant gas giants, we are continually refining our models and deepening our understanding of how these planets work. The mysteries of Neptune's blue color are far from solved, but with every new discovery, we are one step closer to understanding how light and gases combine to create the stunning visual spectacle that is Neptune. Neptune's striking blue color is not just a visual wonder. It's an essential clue in the larger puzzle of planetary science. Understanding why Neptune is blue can tell us much more than just how light interacts with methane. It provides us with insights into the nature of atmospheres, the role of gases in shaping planetary climates, and how different conditions on distant worlds affect their appearance. Moreover, studying Neptune's atmosphere gives us a unique opportunity to learn more about other exoplanets, those that lie outside our solar system. Many exoplanets, like Neptune, are gas giants with atmospheres that could behave in similar ways. By studying the blue planet at the edge of our solar system, we gain invaluable knowledge that could help us understand planets that are millions or even billions of light years away. Neptune's blue color is not just a phenomenon of beauty. It's a window into the complexity of the universe itself. It's a reminder that, even in the coldest and most distant corners of the solar system, there are mysteries waiting to be uncovered. The planet's vibrant blue hue, caused by the scattering of light in its methane-rich atmosphere, continues to captivate our curiosity and inspire scientific discovery. As we peer deeper into the cosmos, the study of Neptune's color is just one of many lessons this faraway world has to offer. Each discovery, each piece of knowledge gained, brings us closer to understanding not only Neptune but the vast, enigmatic universe beyond. And so, as we continue to explore and learn, we are reminded that even the smallest detail, the color of a distant planet, can lead us to a deeper understanding of the universe's grandest mysteries.